roving modules are effectively simple wireless serial cables. They operate in a very similar fashion to that of a modem. They have two modes of operation: a data mode, the mode where data is put onto the UART and transmitted over the Wi-Fi interface, or vice versa, and a command mode, a mode where the user may alter the configuration of the module. To enter this command mode, you use a simple escape character sequence. By default, this escape character sequence is $3. To evaluate the roving Wi-Fi modules, the 131 or the 171, there are evaluation kits, but these evaluation kits are typically used for development purposes as well. So for example, if you're using the RN131, you will want to use the RN131 EK. If you're using the RN171, you will want to use the RN171 EK. In the picture shown here, you can see the RN171 EK, and it comprises of the module itself, the battery or USB power interface, a number of status LEDs, reset and mode selection buttons, the TTL UART signals, which you can connect directly to the MCU of your choice. In addition to that, the TTL connections are sent to a USB conversion IC so that you can use it with a terminal emulation package on a PC or a Mac. And there is also a set of interfaces for sensors. These sensors may be connected to the module's GPIO or A to D converters, for example. In this diagram you can see our end goal. You can see what we're hoping to achieve. We want our wireless module, controlled by our embedded system, our microcontroller, to talk with a Wi-Fi network. This is done with a TX-RX transmit and receive serial connection. In this updated diagram, you can see we've replaced the microcontroller with a personal computer. The personal computer can run a terminal emulation program such as TerraTerm or CoolTerm, and with that we can learn how to control the microcontroller and send data across a Wi-Fi network. Okay, so now we understand the concept. Let's actually use the evaluation kit along with the PC. So the first step is to join the evaluation kit to the PC using the USB cable. Then we go to our setup settings. In the serial port settings we want to see 9600 baud rate, a data rate of 8-bit, parity none, stop bit 1, and flow control none. Once we've done that, we can press the reset button on the board itself. Once we do this, the board will reply back with the firmware version, in this case Wi-Fi version 2.44, the build date, and the module that's being used, along with its MAC address. Once we've done that, we know we have managed to get contact with the board. So we can enter the command mode using the $$. Once we do that, it will reply back that it's in command mode. And we can once again ask it, using its version, what it is, and you should see that the data is exactly the same. We can use the API to find out a little bit more about the module. By using the ls command, we can actually see the files that are in the file structure. You can see that in position 2 we have the firmware itself. In position 23 we have an application called WPS-app, and in position 35 we have the config file, which contains all the variables associated with the module itself. We can see here that it's going to boot up using the file in position 2, which, as we know, is the firmware itself. So now we've done that, let's have a little look at some of the settings that we have. We can use the get everything command to do that, or we can use shorthand, in this case get e, to do exactly the same thing. Here we have a long list of variables that are configured in the config file, but we may want to look at just a subset. So we can look at things like show the network settings. In this case now you can see that this particular module is set up to look for an SSID called roving 1. But because roving 1 doesn't exist, you can see that it has in fact failed to associate with it. So let's see what SSIDs are available in the area using the scan command. By sending the scan command, the module would go out, survey the area and come back with the appropriate results. So we have 1 here with a RSSI of -41 with the MAC address as listed appropriately, along with its name, UBNT. We have another one with equally close information. In this case it's Britville test. We can now join the first one using the join command. We mustn't forget the spaces when we do this. So if we want to join number 1, we can do join space hash space 1, which will help us join UBNT. Alternatively, we can actually name it. So join UBNT. Because UBNT is in capitals, we must therefore join capitals UBNT. So here we go, we press enter to see where we can join it. But of course it failed, we have an authentication error. And the reason for this is because the module does not know the password for that network. So we must set that setting. So we can use the set WLAN password and then the appropriate password. However, of course, as we've introduced to you, we can use shorthand. So set password, and in this case it's RubyGirl1. If we now do that, we get a response that OK. So now if we try and join that network that we tried to join earlier, you will see that now we associated with it. So we are now in fact connected to the UBNT network. A very simple but easy to use API.